Thank you all for joining us for today's Azure Architecture Series webcast, Windows Azure Application Architectures and Design Patterns, presented by David Pallman. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by David Pallman, Neudesic's General Manager of the Custom Application Development Practice. We are very excited to have him present for us this morning. Today's webcast is part of our Azure Architecture Series. We will be hosting the next webcast, Windows Azure Architecting for a Cost, on October 14th. We will be sending out more information about this webcast along with this webcast recording shortly. If you are logged on, you should all be able to see the slide title that states Neudesic. There was a brief intro earlier regarding the features within my meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using a seating chart within live meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the Feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when this link is available. If everyone is ready, please make sure your seat color is green. At this time, I'd like to turn our presentation over to David.
Thank you, Amy. Let's bring up our slides. Okay. We're here today to talk about Windows Azure Application Architecture, and I'm actually giving this webcast today live from the Microsoft Build Conference in Anaheim, California. And if you haven't been tracking that, that's something that you can watch the keynotes online or after the fact, so the sessions at the buildwindows.com site. I encourage you to do so. Microsoft's got a lot of new information to share. Okay. So this is the 7th, I believe, in our series on Windows Azure Architecture. And in the past, we have covered these different areas of the platform service by service. So we talked about compute, we talked about storage, we talked about relational data, we talked about communication, we talked about security, we talked about network architecture. Here we're putting all together. What does an application actually look like? Because most applications, of course, are going to use more than one service. And then next month, the final segment will be on architecting for cost, how you take costs in the cloud into consideration when it's different dynamics than it would be with traditional application development. So our agenda today is we're going to look at how you combine the different services in the platform into an application. We're going to contrast some traditional architectures versus some newer trends we see. And we're going to talk about some things topically: state, load balancing, portability of your application, handling security, and some behaviors that are kind of costly. So when we talk about applications on the cloud, we typically start thinking about the compute service first. You don't have to host your application in the cloud to use the cloud. I know somebody who uses the cloud just for backup, for example. But the vast majority of us who use the cloud will be hosting our application in the cloud as well as using other services. And so when that's the case, that's very much the right starting point. Compute, as I've said in the past, is a more intimate form of cloud computing than other services because you're not just making use of the cloud, you're actually living there. You're making it your software's home. And in the compute service, we have, as we've covered in the past, we have the layers of your application are called roles, and they are made up of instances, and they're elastic. So in a particular application, we're going to have at least one role, maybe more than one of them, and they're going to have some number of virtual machines, and we can elastically increase or decrease the number of those machines as we see fit. Also, the VMs are very much need to be stateless. One of the things about roles in VMs is that they're reliable and unreliable at the same time. If I tell Windows Azure I want a role with 3 VMs, 3 instances, it's going to give me that. It's going to maintain that no matter what. But those individual VMs can disappear and get recreated. That'll happen because of hardware failure. That'll happen because the Cloud Center needs to reorganize itself. And so I can't trust the permanence of state, whether I'm talking about memory or local disk in any of these VMs. And that's a key thing to understand. The compute farm is a very great thing, but when it comes to persistence, you need to be using something external, such as these other cloud services. We also need a way to communicate with our roles, and so we have endpoints. We have public endpoints, which allow, for example, web traffic to hit a website that you put in the cloud. We also have internal endpoints. I might, for example, have a web service that I only want my website to be able to consume. And as I said, we are going to interconnect to external services for at least storage, minimally, if not other things. So if we start with hosting in the cloud for our application, and we're certainly going to be using other services, what are those other services that we might be using? So I'm going to go through a bunch of them now, taking a tour of the other services you might connect up with your application. You're not going to use all of them, certainly, but you're going to be using surely 2 or 3 or 4 of them. First, we have the storage service. This is a primitive storage, not database storage, and it's persistent. We have triple redundancy of the data. And we get blob storage, which is similar to file storage. We get queue storage, and we get table storage, which is just kind of like big, cheap data tables without any relational capabilities. And the way we access that is HTTP REST. And this is after compute is the most commonly used service. Then we have the content delivery network, which originally in Windows Azure was really sort of an extension of Windows Azure Storage. It gives you this 24 edge cache servers around the world for performing caching based on location, and it used to only cache blob content. But now it can also cache applications supplied by your application, dynamic content. And the way you access that is you simply have different DNS, different URL prefix for your cache storage. You might use that, for example, for images or video on your website. Then we have the SQL Azure database. We mentioned primitive storage, but we also have full relational storage. This also has triple redundancy. And the interface here is tabular data stream, or TDS. In other words, the SQL Server protocol. And it's kept that way for compatibility reasons. We do have some limits. There's a limit on database size, just currently 50 gigabytes. And so if you go larger, you need to look at partitioning. Also, it's important to think about things like retries. You might not be used to that in your database programming on-premise, but in the cloud, you always need to think about retries. We have SQL Azure reporting. This is very similar experience to SQL Server reporting services, and you would develop it with the same tools, PIDS, and you get reporting endpoints, URLs, and the data is being reported against your SQL Azure database. Next up, SQL Azure OData service. This service will take a SQL Azure database and give you an automatic data access web service for it using the OData protocol. OData, if you're not familiar with it, combines REST, JSON, Atom Pub into an easily consumable web interface, not only for querying data, but also updating it. SQL Azure Data Sync service will take your SQL Azure database and synchronize it up to one or more other databases. So those databases can be other SQL Azure databases, for example, in other data centers, or they can be on-premise SQL Server databases. And we have Windows Azure Connect. Windows Azure Connect is going to let you create a VPN connection between your one or more roles in the cloud and local machines on-premise. It does require you to install an agent on all of these machines. And then you can get things by DNS. So, for example, I could have an ASP.NET web application in the cloud that accesses a SQL Server database that's on-premise, and that'll work. If I want to, I can even go the extra mile and join my roles in the cloud to my local domain and make it subject to its policies. This is limited to Windows machines only, I should point out today. Okay, App Fabric Service Bus. This is the publish-subscribe communication using the cloud as a communication relay. It's extremely good at getting through firewalls and NATs and such, and so it can really connect parties no matter where they are. It's really good for business-to-business scenarios. And the interface, you can get at it using Windows Communication Foundation, but you can also get at it using HTTP REST. Access Control Service. This is for federated identity. So if you've got a need for single sign-on, if you need support more than one security scheme, the Access Control Service is a fantastic service for easily doing that. Typically, the way you're going to get at that, the easy way to get at it, if you do .NET programming, is to use WIF, Windows Identity Foundation. I want to point out this is not the only way to do security in the cloud. You can pretty much do security any way you'd like to, but this is an important tool that makes security a lot simpler than it has been in the past. App Fabric caching. This is one of several services that will help you with performance. This is a distributed memory cache, and so instead of caching, within your own application, which doesn't work very well in a stateless server farm scenario, this is a dedicated memory cache that's reliable, and you get it through a .NET API. If you're familiar with the Windows Server App Fabric caching, which was codenamed Velocity, it's the same programming model and the same capabilities. Data Market. This is a place to buy and sell reference data. And at first, it seems like just a website, and so there's a website component to it so that you can discover it. So that's at that Data Market at Azure.com. But the nice thing about it is when it comes to consuming the data that you subscribe to, you can use the OData interface, and you can also sell your own data on it. So your application is certainly not going to use all these services, but it surely will use some of them. So when you're figuring out what your application looks like in the cloud, that's one of the first questions is which services am I going to be consuming, and then how are they going to interact with each other. So in the case of cloud development, you often approach things different in a migration than you will in new development. In new development, you have some new capabilities in the cloud, and you might well do things differently than in the case of migration. In a migration, of course, you want to change as little as possible. So you want to keep your expenses down. So what you'll find is when it comes to migrating the compute stuff, let's say you had an ASP.NET application or a PHP application or something like that, you're going to find the migration of compute is the executable part of your app. It's generally pretty straightforward. A few things you need to address. Sessions. We don't have any kind of, so if you're doing session state, it needs to be durable. And so, for example, if you were durable already using SQL Server session state, you can switch that to SQL Azure session state. There are a few other choices. Talk more about state and sessions later. We need to make sure they're addressed properly. If your application used file storage, you need to switch it over to blob storage. Not hard to do, but the API is different, so it does need some code changes. If you're using queuing on-premise, like, for example, Microsoft Message Queue, you switch it over to the Windows Azure queues, or if you need really sophisticated queuing, there's new queuing in the Service Bus part of the platform. If you're using database storage, say SQL Server or something else like MySQL or Oracle, SQL Azure Database Service would be the likely choice. However, some people do elect to move things over into Windows Azure Table Storage if they don't have a heavy relational need because of the lower cost. If you have one of your applications that you're migrating has internal integrations to other systems that aren't externally accessible, well, you could put some external web services to provide that connectivity, or you could use the Windows Azure Connect service to create that VPN connection, and then you'll be able to access those internal systems. What about security integrations? Well, let's say your migrated app was using domain security. You can still do that. One way to do that is to install ADFS, Active Directory Federation Services. Another would be to use Windows Azure Connect and connect directly to your AD domain controller. You do need to watch out for some semantic differences. For example, Windows Azure queues are different to MSM queue. They have sort of a two-phase interaction where you get a message, process it, and delete it. That's different than the semantics of MSM queue. And there are some subtle differences. I already mentioned retries on things like database processing. It is very important when you access Internet services in the cloud to code for retries. Now, if you've been practicing service-oriented architecture, SOA, then you're going to find you're going to have an easier time moving things to the cloud, because SOA fits the cloud very, very well. And those principles that SOA has, like clearly defined service boundaries, being as stateless as possible, using interoperable standards, loose coupling, and coarse-grained interfaces, all of those things are doubly important and good in the cloud. So you're ahead of the game if you've been doing SOA already. So let's look at some different architectures and how they would work in the cloud. If you look at the left-hand side here, we have something a common on-premise design where we have outside our firewall on the perimeter network in the DMZ, we have a web farm, and then internally we have web services, some kind of backend, maybe database that we want to talk to, and that backend is behind a firewall, and because we have a trust relationship, the externally accessible web farm can talk to its backend. How would you do something like that in Windows Azure? Well, we don't get a programmable firewall per se in Windows Azure, but we can do the equivalent using the compute service model, as it's called. So if we create a role, on the right-hand side you see we have two roles. One of the roles has what we call an input endpoint, a public endpoint. That makes it accessible. That's like being outside the firewall. And the internal one has an internal endpoint. That's an endpoint that only other parts of the cloud solution can hit. And so we can have the equivalent topology. We just have to think about it a little differently in terms of the building blocks we want and what they're called. Let's look at another example. What if we had, again, a public website outside the firewall, and behind the scenes we had batch workers. It's a common pattern to have just a bunch of workers that do batch processing or workflow or something like that, feeding off a queue. And how would you do something like that in the cloud? Well, it would be very similar. Again, you'd have a role with a public endpoint to do the equivalent of the website, and you can use the worker role in Windows Azure and a Windows Azure queue to feed to load balance effectively data to your background workers. Works very similarly, works very well. One more example. A very common, simple type of application design is I've got a web application that talks directly to a database, and I don't have any kind of intermediate web services. Once again, we can do a web role with a public endpoint, but instead of having to host a database in the cloud, we can just use the SQL Azure Database Service. We can consume the service directly. We don't have to go and allocate VMs and install and manage any kind of database products. So for migration, you might do things the traditional way, and really, you're perfectly free to architect things the way you are used to in the past in the cloud, as long as you follow these rules about remembering you're in a redundant environment and that state has to be persistent. But there are newer architectural influences going on that might change the way you want to do things, and you should at least know about them. So big influences today are from cloud, from mobility, from REST, from the NoSQL movement. So some of the trends we see are fewer layers and simpler layers. REST-based services are really big now. Some anti-patterns for the cloud in particular are complexity. Locking in transactions have really fallen out of favor compared to a couple of decades back. Doesn't mean you can't use them, but you're encouraged to minimize them. Even database, something not going away, but it's been de-emphasized in terms of the only way I store things. You'll see primitive storage like Windows Azure table storage and such, blob storage. Definitely has a place for that. So a database remains important, but not supreme. I guess that's the right way to think about it. And there are some new concurrency mechanisms that don't hold resources hostage the way things like locking transactions do. So, for example, we have something called e-tags in Windows Azure, or versioning of data, really, that you might want to look into. Also, we have such a robust set of services in the cloud. We have some new capabilities. We haven't had a service bus or an access control service in the past. And if our app is making fair use of the cloud, then we can take elasticity and scale for granted in a way that we couldn't take it for granted in the past. So all of this will influence your design. So I just want to kind of contrast that. Let's say you have a traditional approach, the traditional three-tier architecture. It's got a presentation layer, a business web services layer, and a data layer, and it's a safer web solution. And you want to move that to the cloud. Well, you can certainly just do that way. Whether it's an old app or a new app you're developing, you can certainly follow that model, and there's nothing wrong with that. That will work, and that's fine. In case of Windows Azure, this would be the presentation and web services would be in either one or two web roles they could share. The data would be SQL Azure Database Service. But what's maybe a more modern way to do something like that? Well, I could say to myself, we're in this world here where I'm not just going to be consuming my server, my app servers, web services. A lot of corporations now, their web services, they have lots of web services. You don't put this in one, you consume many of them. So the idea of having a sort of a central server kind of maybe goes away a little bit when you consider that maybe you have multiple web services. Plus, in addition to your own application services, you have the ability to do identity now just by directly hitting an identity service. That could be ADFS for your domain login. That could be the access control service. That could be a web identity like LiveID or Google or Yahoo or Facebook. But a separate service from elsewhere that you hit, an identity provider. And then you might not you might want to say to yourself, well, I'm hosting my app in the cloud, but I also am using these cloud services, and I don't really have to go through my application server to get to all these services. My client over on the website could hit some of these services directly. For example, it might pull images from Windows Azure Blob Storage directly in the HTML of your web pages. It doesn't really need to go back to the application web server to do that. So we see this fracturing, this balkanization of services. Services remain strong, but the idea of going to a central server, we're seeing less of that. We're seeing more of a mosaic of services that we consume. And this effect is not at all confined to the back end. Some very interesting things are happening on the front end. People want to support web browsers, phones, tablets, big screens. And although you can do those with separate implementations, you might have seen mobile websites or native mobile applications. The big trend today with HTML5 in particular is kind of one solution that adaptively takes care of everything. So that puts us in this world where we have lots of different apps consuming these services. In fact, even for a single user, that one user may go between different devices. And so the world starts to look like this. It's decentralized quite a bit. Cloud service is very important. The front end, the supporting devices and such are very important. But less of a central point where the application's brains are. It's more about just being able to run anywhere, being able to run everywhere. So where does state live? Well, that's mostly going to be in the data more than anywhere else. Data is what's going to keep state. On the cloud side, data is going to keep the continuity of user and session. And on the device side, cookies and such, as well as local storage, things like caching, are going to help the back end understand who's on the front end. So that's very different from that typical three-tier architecture I showed a while back. Nobody's forcing you into this, but this is where the world is going. And so as you have an opportunity to, especially with new application development, you might want to consider carefully how much of the old and how much of the new you want to have in your architecture. So let's talk about some of these different aspects in a little more detail. So state. If your application, especially when you're migrating, you used to do session state in memory. For example, you ran on a single server, your web application, you did your in-proc session state. That's not going to work in Windows Azure. You've got to have, state needs to be durable, and it needs to be outside of the compute VM farm. So you can do that in a couple ways. You can use Windows Azure Table Storage. There's a provider or a sample for each of these, or you can use the SQL Azure Database. Or you can use App Fabric caching. That's not super durable, but that might be all you need to temporarily cache session state. And you'll typically use cookies as part of your mechanism here, because each request that a client makes to your web role, say, the round robin is the load balancing is just total round robin. So each request will probably go to a different server. And so you really depend on something like a cookie mechanism to understand what session somebody's using. Now for load balancing, some people have client affinity or server affinity, they might call it, sticky load balancing, where a request goes to the same server each time for a particular client. We don't have that, at least out of box, in case of Windows Azure. So if that's your world, you have to either change it to not care, or it's actually possible to build a sticky HTTP session router. In fact, Ryan Dunn has blogged and put code out on how to do that. So it is possible to do sticky routing if you're willing to pay the cost of hosting that router. But most of us really choose to simply do state in a way that we don't have to worry about that. So another consideration might be portability. You might be saying, well, the cloud's really cool, but I really want to reserve the right to take my application and run it in the cloud, but also keep running it. Perhaps I want to move it back on premise. I don't want to lose that option. I don't want to be locked in. Okay, so that's fine. If you want to do that, then you're going to need to limit yourself over to common ground. So what's an example of common ground? Well, let's take the SQL Azure Database service, for example. It's got the same protocol and programming model as SQL Server. So switching to SQL Azure doesn't lock you in any way, because switching back to SQL Server from SQL Azure is just a connection string difference. On the other hand, something like Service Bus or Access Control Service, these are services that are new. We haven't had them before, and so yes, if you decide to leverage them, which you might have good reason to, yes, that'll be harder to go back. You'd have to make some changes. Sometimes, though, you can accommodate minor areas of difference between cloud and on-premise through what's called separation of concerns. So here's an example. Let's say you had an application that you were migrating to the cloud, and the application on-premise used file storage. Well, you don't have file storage that's durable in the cloud. What you do have is blob storage, but the API is different. So what do you do? Well, you could create either an interface or a service. You create an iFile storage interface and say that I have two implementations. One that actually stores and retrieves files as files. That's the implementation I use on premise, and another implementation that does it with blob storage. By doing it that way, really most of the application is unaware of these differences. So 95% of the application is common code, and you've isolated this one area difference into a nice modular area where it's easy to switch out. Talk a little bit about security. I mentioned earlier that you can do security any way you want to, but there are three key security technologies you ought to know about that are pretty compelling. The future is what we call claims-based security, and it's very open-ended and works well for web identities as well as domain identity. The three key technologies are WIF, Windows Identity Foundation. That's the library your .NET application can use to get at security services. The second is ADFS. That's going to give you Active Directory domain authentication from the outside. And it's very well engineered to be carefully controllable by your IT department, so there's no vulnerability about using it. And the Access Control Service, which really gives you a federated security, the ability to have single sign-on, and really using these technologies decouple from your app any kind of hard-coded particular security implementation, especially using the Access Control Service. You really are letting it front-end security for you. You do security one way, but your application can support many different schemes. And then just a note on constant behaviors. We'll have a lot more on this in our final segment in this series. But leaving apps out there that you don't need anymore, or leaving data allocated that you don't need anymore, is going to cost you more money month after month. Looping on storage, like pulling on a queue, can be an expensive operation. Any kind of bloated or unnecessary I/O, since you do pay for bandwidth, is going to cost you money. Failing to leverage caching is perhaps going to be costly to you. And also overly chatty interfaces. So when you're going over the internet to some cloud services, is not a terribly good idea. So last thing I want to talk about just a little bit was there's a big revolution going on with web applications, and it's driven by HTML5 and devices and social media and cloud computing. And I just want to kind of point out that since most cloud applications are web applications, we shouldn't ignore these other influences. Cloud computing all by itself is making a lot of architectural changes that we just talked about, but so are these other things like HTML5 and devices. So I just want to talk a little bit about how both the back end and the front end of the web is changing, and that these changes they're not mutually exclusive. They do affect each other. So here's a few years back how we did web solutions. We would have a server running IIS, say, or maybe several servers. We'd use IIS and ASP.NET. We'd use WCF for our web services, and we use SQL Server for our database most typically. And on the browser, we'd be running typically HTML, CSS, and JavaScript, but not very much of that. Really, the server did all the work, set up the pages. The browser did very little. But then over the years, things started to change a little bit. We started to get more interactive. We got things like Ajax. And in the Microsoft world, we got things like Silverlight, because of the Flash market. And technology like that would let us, kind of nice. They would give us, in case of Silverlight, it would give us .NET over on the browser side, and nice things like XAML. And so we're able to do very sophisticated things. But a big shift was happening here because more of the application now started to live over on the web client side, on the browser, to run in the browser. And we had to get real comfortable with highly asynchronous programming. But now we're moving into an era where, for example, on the iPad and the iPhone, Flash isn't allowed. If you really want your applications to run everywhere, the best way to do that going forward is to look at the HTML5 family of technologies, which we'll be able to find. If you want something that runs everywhere, this is going to be the way to do it. So HTML5, CSS3, scalable vector graphics, JavaScript, kind of the big story now on the web client side. And that allows us to have these apps that run in more than one place. instead of separate implementations for every device. Does mean a high dependence on JavaScript and open source libraries. Now this doesn't say, if you're a .NET person like I am, that we stop using .NET at all, but it does mean that you're going to find a big movement that there's a lot for open standards on the web client side, and your proprietary technologies are more typically going to be on the web server side. And again, more of the application being now on the web client side than in the past. So, and not getting rid of the server at all, but diminishing it. And then, of course, we could put that back in the cloud, as we've been talking about. Windows Azure instead of Windows Server. ASP, we might use a lot of the same technologies, ASP.NET, WCF, SQL Azure instead of SQL Server. And so the modern app doesn't look too different here, but there are some differences, right? In addition, as we said earlier, we're probably going to be consuming not just your web server services, we're probably going to be consuming other services, directly consuming from the client side, cloud services, and perhaps external services like a delivery service or a map service or something like that. So at this point, we can take some questions if there are any.
Great. Thank you, David, for this great presentation. We did have a few questions come through. As a reminder, to ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen. Type your question and click the Ask button. The first question that I did get through was, can a Windows application use Windows Azure?
Okay, great question. So we've been talking about applications and mostly saying, 9 times out of 10 of the web applications, which is the case. But what about something like a desktop application, like a Windows application? Or actually this week I've been here at the Build conference learning about Windows 8 and how Windows 8 application might use the cloud. Well, so the answer to that question is, sure. All of these services I mentioned are available for consumption not only by apps you host in the cloud, like a web application, but any apps. So your on-premise desktop app, or for that matter, a server app, can go out and consume these same services. They can use SQL Azure Database for storage and Windows Azure Storage and Access Control Service and so on and so on. So absolutely, there's no reason at all why any application can't leverage the cloud services.
Great, thank you. Another question that did come through, how does Windows Azure compare to Amazon Web Services architecturally?
Okay, so how does Windows Azure compare to Amazon Web Services in terms of all this? Great question. So they're certainly not identical. There are a lot of things you can do that you might do the same way between the two, but they're not identical. Like Windows Azure, Amazon has a number of services. Some of them are for data storage, different things like that. So as far as taking the compute layer, something that you would run in a web farm, I don't think things are too differently there, but you have the same situation where the VMs aren't guaranteed to stay around and be persistent. So you've got to figure out something to do with your durable storage and how you're going to handle security and caching and things. And so both platforms have a lot of services, not identical. Now Microsoft leans a lot more towards what we call platform as a service, a lot more automated management and such for you. Amazon is a little more of the familiar set up yourself. So I think some of these newer architectures that we're talking about, where I let the cloud do more, and I'm more decentralized, I think Windows Azure does have an edge there. If you're doing more the traditional 3-tier architecture, and you're really just thinking of the cloud as sort of a place to host, in other words, if you haven't really discovered the amplified uses of the cloud yet, you're just thinking of it as another place to host, and probably it's an equivalent experience for you, both platforms.
Great, thank you, David. If anyone has any more questions, please feel free to type them in at this time. All right. Looks like we did have a few more come through.
Great.
Can you please talk about Azure Async Cloud Eventing? What is it and its scope of usage?
Can you please talk about Azure Async Cloud Eventing? What is it and its scope of it? Wow. Well, I have to confess, I have not heard that term before. Maybe that's something brand new. There is an update to Azure coming this week. It's in fact being talked about right now as I speak to you. The keynote's going on and the latest Azure release is being discussed. So eventing is very interesting, right? In the case of most of our architectures, as we moved into a more asynchronous programming model over the last 5 years, especially, we see that on the client side, usually controls that, right? I issue an asynchronous request. I don't worry about waiting for the response. I want to stay responsive, and when the answer comes back, I do it. How does the cloud, how does the back end proactively send you things? So a couple ways about doing that I know of, because you want to avoid the client just polling all the time, because that would be kind of wasteful, especially if you had a lot of clients. So there is something on the Windows Phone side where you have push notifications, where you can emanate something, and we've had something all along on WCF, Windows Communication Foundation, called the duplex pattern, where the server can initiate communication. So I think if I was looking to do something along the lines of the server initiating a communication back to the front end, then I would probably look at WCF duplex communication.
Great. Thank you, David. All right. Again, if anyone has any more questions, please.
You know what? I'm sorry, Amy. I'm sorry, but I flaked on one of the good answers to your question, which is the Windows Azure Service Bus, and that's probably what you're referring to when you said eventing. The App Fabric Service Bus in Windows Azure is this hub-sub type of communication model. It can have any number of senders, any number of receivers, and it supports eventing, as they call it, or multicasting. So you can do like chat programs and things very easily. And so I think that's probably what you were referring to. So there's something where any of the parties communicating can send a message to either one party or all the parties, and so it gets away from the old client-server architecture where the client has to initiate everything, and it's very, very sophisticated. So if you're looking for eventing, that's what I would look at, the Service Bus.
Great. Perfect. Thank you. All right. If there is no other questions at this time, I'm going to go ahead and click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business? Yes or no? Great, thank you. And the next question, please rate the presentation content, excellent, good, or poor. All right, and the last question I have for you, would you like us to schedule a follow-up, yes or no? Great. We will be forwarding the link to view a recording of this webcast once it becomes available. If you have any further questions about this presentation, please feel free to email David at the email address provided on the slide. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are free to disconnect. Thank you.